My name is Louise D'Souza and I'm the British Ambassador in Chile, and I'm delighted to be here to welcome all of those who join us for this event on the commercial opportunities in water management between our two countries, which falls at a very timely moment in the Chile-UK relationship. I want to start by highlighting the strong collaboration between Chile and the UK on climate and environment issues in the context of our COP25 and COP26 partnership. With back-to-back presidencies, we have developed a uniquely strong collaboration. At COP26 in Glasgow, the UK encouraged all countries to sign up to the international initiatives on the table, and Chile was the country in Latin America that signed up to the most initiatives. Chile has also recently enshrined its net zero commitment by 2050 into law, and the new administration, which took office last month, is pledging to go even further than these commitments, which were made by the previous administration. So UK companies will find willing partners here in Chile. As we all know, the impacts of climate change are already being felt in many parts of the world, and Chile is no exception. In fact, we know Chile is highly vulnerable to climate change. It displays 7 of 9 UN climate vulnerability markers. And these impacts are affecting the livelihood of thousands of people, especially in the most vulnerable communities, reducing even further the capacity of ecosystems and individuals to adapt. And adaptation is going to be one of the clear focuses of this new government here in Chile. One of the clearest examples of these impacts is the severe drought that Chile has been facing for more than a decade now. Rainfall is down by 75% in the central region, and 72% of the country is suffering some degree of water shortage. 6 of its 16 regions have declared a state of environmental emergency. In addition to the implications for Chile's water security, this is also affecting the country's energy security. For example, we have seen how the government has had to intervene with specific regulations to avoid more drastic electricity rationing measures as a result of lower output from hydroelectric power plants. So addressing water challenges is definitely one of the top priorities of the recently elected government, not only from the environmental perspective, but throughout all economic sectors. This is key. In addition, water is a key topic in the ongoing discussions on a new constitution for Chile, which are due to finalise in July. And this reflects Chile's commitment to improving water resource management standards. It represents a unique opportunity to strengthen institutions with competence in the matter of water management and to generate legal certainty for the development of the sector. It is in this context that we see a real opportunity to further strengthen our collaboration with Chile. We want to facilitate the exchange of experience, showcase the expertise and technological offer of the UK, and at the same time, support stakeholders in both countries to help adapt to the challenges that climate change is putting before us. So I hope that this session is a good first step in establishing those communication channels. And I encourage you to take advantage of the findings of the study that we are presenting at this event, which I think you will find extremely useful. So I wish you a successful event. I hope this is fruitful for everyone. As Sebastian has already mentioned, please do tell us who you are, tell us what your interests are, and follow up with us at the embassy on the issues raised here today, and indeed on any other questions you have on the sector as we work to help support collaboration in the area. Thank you very much, and wishing you a successful event.
Thank you very much, Ambassador, for your opening words. Chile's water security is indeed threatened by climate change, and while mitigation efforts can avoid some of the long-term impacts, adaptation actions are urgently needed. This is why our British Embassy is seeking to promote the interaction between the UK and Chile regarding top priority adaptation challenges. And for Chile, when it comes to be about adaptation challenges, water management improvement efforts are the #1 priority. We aim to support Chilean water management efforts by identifying ways in which UK expertise can help address water-related challenges in this context. Through this project and with the support of Implementa Sur, we identified specific collaboration opportunities. We examined the market barriers for these opportunities and identified ways in which our embassy can keep on supporting collaboration initiatives between both countries, based on the recommendations made by Implementa Sur. Regarding the latter, here at the embassy, we are currently analyzing the recommendations made and defining our next step. Within this next step, your input and feedback, as our ambassador Luis just said, will be essential. So please include your thoughts and questions in the chat box. And also please do feel free to reach out to us after this webinar. Now, Hernan Lopez and Martin Beauvillier, our colleagues from Implementa Sur, will share with us the main results of this project. After this, Eddie Maloney, head of water at the Department of International Trade, or TIT, will share with us a presentation on the UK water industry. We will then have a question and answer section. And to finalize, Hernan and myself will share some closing remarks. Before we start with Implementa Sur presentation, I would like to briefly introduce to you Martin and Hernan. Martin Beauvillier is a consultant engineer at Implementa Sur with experience in environmental and energy markets, especially in renewable energy. Martin has a civil industrial engineering degree with a diploma in environmental engineering from the Pontificia Universidad Católica de Chile. Hernan Lopez is a lead consultant engineer at Implementa Sur. He has over 5 years of experience in the renewable energy market, experience in climate finance strategy, energy purchase agreements, and energy efficiency policies and regulations. Since 2019, Hernan has been part of Implementa Sur, supporting the development of studies in energy, water resources, and climate change. He has a civil electrical engineering degree from the Pontificia Universidad Católica de Chile and a Master of Science degree in energy and nuclear engineering from Politecnico di Torino. I will leave you now with Martin so he can present us the main results of this study. Go ahead, Martin. Thank you.
Muchas gracias, Sebastián, por la presentación. Muy buenos días a todos y todas. A continuación, haré la presentación de nuestro estudio en conjunto a la Embajada Británica sobre oportunidades comerciales en Chile y el Reino Unido respecto a manejo hídrico, en donde, como comentó Sebastián, la Embajada comisionó a Implementa Sur para llevar a cabo un estudio que buscara, por una parte, las necesidades chilenas en lo que es el manejo hídrico y, por otra parte, las capacidades del Reino Unido y que creara oportunidades comerciales para ambos en este tema. Presentando brevemente el contenido que se verá, primero que todo hablaré sobre el objetivo de este estudio y un contexto general de la situación del agua en Chile. Luego, y pasando al estudio mismo, se verá la clasificación general de las soluciones a las problemáticas encontradas y cómo estas fueron priorizadas. Después, se presentarán los principales habilitadores y barreras para la inserción de las tecnologías priorizadas en el mercado chileno y, por último, se harán las recomendaciones generales de acuerdo a los estudios hechos sobre las acciones que podrían hacer entidades interesadas en el desarrollo de este mercado en Chile.
Martin, please let me interrupt you. The interpretation is not working right now, so I'd rather fix that up since we have an audience from the UK and we want them, of course, to follow what we are saying.
Me parece, Sebastián, que tienen que cambiar de canal nuevamente.
Okay, dame un minuto, por favor.
Yeah, good morning. Yes, good morning, everyone. For those who are looking for the translation, please look for the channel on the bottom of the screen and select the English language. Then you will hear the translator on this channel, and I can hear. Grateful if we could all, the person who was asking for that has confirmed that he can hear. Thank you. We can proceed with the presentation. Martín, podemos proceder. Gracias.
Okay, thank you, Lina. Go ahead, Martín. Thank you. Sorry for that.
All right. Bueno, Entonces, continuando con los objetivos de este estudio, tenemos que este estudio tuvo por objetivo tres principales. El primero fue la identificación de oportunidades para el desarrollo de negocios en el manejo hídrico entre el Reino Unido y Chile. El segundo fue la priorización de tres soluciones y su posterior caracterización en cuanto a sus habilitadores y barreras para la inserción de estas soluciones en Chile. Y el tercero fue el de brindar información comercial para las empresas del Reino Unido que deseen participar en el mercado chileno, información que pudiese facilitar el esquema de financiamiento local y las oportunidades para ingresar a este mercado. Establecidos los objetivos y explicando el contexto hídrico chileno, tenemos que en cuanto a la oferta de agua, Chile está dividido en 1020 subcuencas hidrogeográficas, las que se van subdividiendo hasta formar aproximadamente 1500 subcuencas. En Chile existen más de 1200 ríos y casi 13.000 cuerpos de agua, entre los que se encuentran lagos y lagunas. La principal vía de almacenamiento de esta agua a lo largo de Chile son las represas, y son estas las que son usadas para abastecer a todos los sectores productivos de la cadena. En el gráfico de la derecha, lo que se puede de la izquierda, perdón, lo que se puede observar es la disponibilidad de agua per cápita para las regiones de Chile, donde se observa que de norte a sur, siendo el norte las regiones con menos número y las del sur las con más alto número, va existiendo cada vez una mayor disponibilidad de agua. En cuanto a la demanda, a la derecha, viene dado principalmente por el sector de la agricultura, que representa más de un 70% del consumo total, con un consumo de casi 8 millones de metros cúbicos al año. A este sector le sigue el de agua potable y sanitización, con un 12% del total. Ahondando un poco más en ambos sectores que están identificados como los de mayor consumo en agua en Chile, vamos a partir con el sector sanitario, particularmente el sector sanitario urbano, que es manejado principalmente por empresas privadas que adquirieron concesiones estatales para el manejo y la distribución del agua. Estas empresas, por sus características, forman monopolios naturales, dado que la gran inversión en infraestructura que tuvieron que hacer hace unos años para abastecer a la actual demanda de más de 16 millones de personas al año para zonas urbanas. El gráfico de la izquierda lo que muestra son las principales sanitarias del país, donde se puede observar cómo 10 sanitarias controlan y administran el 76% de la distribución y tratamientos de aguas del país. En cuanto a las zonas rurales, existía anteriormente un sistema de APR o agua potable rurales que fue recientemente cambiado por uno de servicios sanitarios rurales. Este sistema, que abastece a casi 2 millones de habitantes, funciona a base de cooperativas. ¿Qué es lo que son las cooperativas? Las cooperativas son empresas centradas en las personas y pertenecientes a sus miembros, quienes las controlan y las dirigen. En este sistema, el funcionamiento es a través de un aporte privado de las comunidades rurales mismas, que en conjunto con una subvención estatal financian estructuras de obtención, tratamiento y distribución de aguas. El nuevo cambio de la ley a la Ley de Servicios Sanitarios Rurales lo que hace es comprometer al Estado con la implementación de sistemas de producción, distribución de agua potable y recolección de aguas servidas para las comunidades rurales. En cuanto a la agricultura, que es un tema muy importante en el país porque, como mencionamos anteriormente, es más del 70% del consumo hídrico de Chile, tenemos que la mayor producción está dado, y por ende consumo está dado por las exportadoras, que muchas veces compran los productos a los pequeños y medianos proveedores, además de sus producciones propias. Lo que se muestra en el gráfico son las 10 exportadoras más grandes de Chile y las respectivas miles de toneladas que ellas exportaron entre el 2019 y el 2020. Pasando a un marco institucional chileno para el manejo del agua y siguiendo con el estudio del contexto chileno, tenemos que existen 33 organismos gubernamentales, 4 organizaciones de usuarios y 10 organismos autónomos que manejan los permisos y la institucionalidad del agua en general, de acuerdo al rubro en cual se mueva el proyecto o donde va a estar el énfasis del agua. Lo anterior ha sido fuente de grandes problemas y barreras en la implementación de proyectos en los últimos años, ya que esta estructura de instituciones atomizadas, la llamamos instituciones atomizadas porque son muchas instituciones, ha provocado grandes extensiones y papeleos a la hora de conseguir permisos y aprobar proyectos. En el gráfico, el esquema de la figura, lo que se ve en la columna de la izquierda morada, los ministerios que tienen relación pertinente con la institución acuática, y en sus filas lo que se ve son las entidades públicas que tienen relación y que están ligadas a los ministerios. Actualmente el problema con esta atomización de instituciones es bastante evidente y ya existen planes de cambio para ello. Estos planes de cambio vienen dados por dos frentes principales. El primero es la Convención Constitucional chilena, que se está realizando en este momento y que está escribiendo una nueva constitución, donde el agua asoma como uno de los temas centrales y probablemente, en caso de ser aprobada, va a tener cambios. Y el segundo frente tiene que ver con el nuevo gobierno y sus planes para la creación de un sistema nacional de gestión de agua. Este sistema reemplazaría a muchos de estos organismos y unificaría, dirigiría y coordinaría las competencias del Estado en todo lo que tenga que ver con la materia de agua. La última parte del contexto chileno tiene que ver con la razón por la cual este estudio se realizó y contempla los distintos desafíos que está presentando hoy en Chile por consecuencia del cambio climático. Por ejemplo, uno de estos es la mega sequía que ha afectado más del 72% del territorio nacional en los últimos 10 años y que posiciona hoy a Chile como uno de los 33 países con la mayor escasez de agua estimada al 2040. Otro dato interesante o preocupante desde otro punto de vista es que desde las 41 estaciones de monitoreo que tiene la Dirección General de Aguas, o la DGA, 35 han presentado un déficit de agua severo en los últimos años. Los principales desafíos que se encontraron para Chile entonces hoy en día son, primero, la sequía, que genera degradación de suelos y falta de agua para el consumo humano y actividades industriales. Segundo, las pérdidas de agua, donde las ciudades chilenas muestran más pérdidas de agua en 2021 que otras ciudades similares en el mundo. Tercero, el aumento de la demanda, donde se prevé un aumento de la demanda de un 4,5% al 2030 y de casi un 10% del agua para el 2040. Cuarto, la contaminación del agua, donde ha existido un aumento en los niveles de contaminación y turbidez en ríos, lagos y mares en el último tiempo. Y último, los daños ambientales y desastres naturales, que son riesgos para la infraestructura de las ciudades y las personas que viven en ellas. Estos pueden ser, por ejemplo, aluviones o inundaciones. Yendo a la segunda sección, y una vez que ya se estudió el contexto chileno, sus principales sectores y desafíos en cuanto al manejo y la gestión hídrica, lo que se hizo fue empezar a buscar clasificaciones de soluciones que se adecuaran a la realidad hídrica de nuestro país. La primera clasificación fue basada en un estudio conducido por Fundación Chile en el 2019 respecto a medidas, acciones y soluciones para la seguridad hídrica del país. Este estudio proponía una clasificación general y respectivas soluciones para cada clasificación, las que fueron adaptadas y modificadas según las necesidades que fuimos encontrando a través del estudio. Entonces, la primera clasificación, leyendo desde izquierda a derecha, es la gestión e institucionalidad del agua. Esta clasificación hace referencia a los mecanismos institucionales, legales y educativos que facilitan la gestión hídrica, y hace referencia también a las aguas y gestiones estatales principalmente. Dentro de esta clasificación tenemos la solución de monitoreo y teledetección, que hace referencia al monitoreo de los recursos hídricos estatales, como pueden ser cuencas o aguas subterráneas, y mide algunos aspectos como niveles pesométricos o sus composiciones químicas. La segunda clasificación es la conservación y protección de los ecosistemas acuáticos, que son donde entran las medidas para proteger las fuentes de agua actuales y las futuras. Dentro de esta clasificación tenemos dos soluciones. La primera, la de conservación, que hace referencia a la conservación de los glaciares, y la segunda, la de infiltración y recarga de acuíferos, que hace referencia a la infiltración ya sea por medios naturales, como soluciones basadas en la naturaleza, o medios artificiales. La tercera clasificación es la eficiencia y el uso estratégico del recurso hídrico, que tiene que ver con todas aquellas medidas, acciones o soluciones relacionadas con la demanda del agua y que promuevan una mayor eficiencia y un uso responsable del recurso hídrico. Acá tenemos dos soluciones. La primera es la de la optimización de la conducción, almacenamiento y distribución, que corresponde a todos aquellos sistemas de conducción de agua, ya sean cerrados o abiertos, o sistemas de limpieza de tuberías. También en este punto se hace referencia a los sistemas de almacenamiento de aguas. La segunda solución de esta clasificación, llamada optimización, tecnificación y automatización del uso de agua, corresponde a las tecnologías para reducir y optimizar el uso del agua, principalmente en los sistemas de riego para la agricultura. Estas tecnologías también incluyen los monitoreos remotos de presión o control de temperaturas para tuberías y redes de alcantarillado. La última clasificación, llamada migración e incorporación de nuevas fuentes de agua, tiene como soluciones la transferencia, que hace referencia a las transferencias entre cuencas o transferencias entre grandes distancias como una carretera hídrica. La captación o cosecha atmosférica, que son todos aquellos sistemas de captación de aguas desde la atmósfera. La desalación, que son todos aquellos sistemas que conducen a desalar el agua de mar para obtener nuevas fuentes de agua. Y por último, el tratamiento y uso de aguas, que son todos aquellos sistemas de tratamiento de aguas residuales y su posterior reutilización, ya sean zonas urbanas o rurales. Este estudio tenía como objetivo la priorización de 3 de las soluciones que se presentaron anteriormente, y para ello se usaron 3 criterios de priorización. El primer criterio fue una revisión bibliográfica, donde a través de la revisión de algunas fuentes bibliográficas del Reino Unido y Chile, lo que se hizo fue tratar de identificar la solución como una oportunidad para ambos países. Esto significa que se trató de identificar la oportunidad como una necesidad para Chile por una parte y como una capacidad tecnológica del Reino Unido por la otra. La segunda priorización, el segundo criterio de priorización viene dado por la existencia de un modelo de negocios, donde las soluciones identificadas en la revisión bibliográfica debían tener un modelo de negocios establecido y conocido. Esto le da una viabilidad técnica y económica a la solución en el corto plazo. Por último, el tercer criterio fueron las entrevistas que se sostuvieron con los actores que se muestran ahí en su pantalla a la derecha, donde se realizaron estas entrevistas con actores públicos y privados de Chile y el Reino Unido para ratificar las soluciones como una necesidad actual de la crisis hídrica chilena y confirmar una oportunidad de negocio atractiva para su implementación en el corto plazo para las empresas del Reino Unido. En este punto también se le pidió a los entrevistados que identificaran las principales tecnologías de cada una de las soluciones. Con lo anterior está este esquema general que, explicándolo un poco a lo más a la izquierda, está la clasificación general. Después está el problema que viene a atacar esta clasificación general. Luego vienen las soluciones que expliqué antes y posteriormente sus tecnologías. Entonces, el siguiente esquema lo que hace es mostrar los resultados de las soluciones priorizadas en conjunto con sus respectivas tecnologías, en donde para una clasificación general de incorporación de nuevas fuentes de agua, donde se tenía un problema de falta y desperdicio de agua, lo que se hizo fue priorizar una solución de tratamiento y uso con sus respectivas tecnologías de tratamiento y uso para zonas rurales y urbanas. Luego, para una clasificación de eficiencia y uso estratégico del recurso hídrico, donde se identificó el problema de que había un aumento de la demanda y una disminución en la oferta de agua, se priorizó la solución de optimización de la conducción, almacenamiento y distribución con sus respectivas tecnologías de construcción de canales de regadío, túneles de desagüe y con puertas automáticas para los canales, que pueden servir muchas veces de almacenamiento. Y por otra parte, para el desafío de pérdidas de agua por infraestructura, se priorizó la solución de optimización, tecnificación y automatización del agua, con sus respectivas tecnologías de sistemas de riego para el consumo en la agricultura y sistemas de monitoreo para tuberías y cañerías. Una vez que se priorizaron las soluciones y sus respectivas tecnologías, se procedió a hacer una caracterización de ellas. Esta caracterización vino dado por una parte por los habilitadores, donde nos encontramos con habilitadores financieros, que son todos aquellos fondos concursables y programas de inversión que promuevan y financien proyectos asociados a la implementación de estas tecnologías. Por otra parte, teníamos habilitadores institucionales, que fueron todas aquellas instituciones u organizaciones que promuevan proyectos de inversión extranjera relacionados con las soluciones priorizadas. Y por último, habilitadores sociales o políticos, que son todas aquellas acciones sociales o políticas que pueden incidir en la facilitación del desarrollo de estas soluciones o la promoción de estas soluciones en Chile. La segunda caracterización vino por mano de las barreras, donde la primera barrera eran barreras económicas o de mercado, que hacían referencia a todos los problemas relacionados con problemas financieros, económicos o de mercado para desarrollar estas tecnologías. Luego teníamos barreras técnicas, que hacían referencia a todos los problemas relacionados con aspectos técnicos o tecnológicos. barreras institucionales, que hacían referencia a todos aquellos problemas relacionados con la institucionalidad chilena o con la normativa del sector o tecnología. Y acá, en vistas de lo que dije antes y en las barreras que voy a decir después, es importante tener en consideración que en general corresponden a la desagregación y atomización de las instituciones del Estado. Por último, la barrera social ambiental, que hacía referencia a todos aquellos problemas relacionados con la cultura o la sociedad chilena, así como los relacionados con el medio ambiente. Existen también algunos habilitadores que fueron comunes a todas las soluciones y que están relacionados con instituciones, empresas o programas que pueden ayudar en el desarrollo de todas las soluciones en conjunto. Estos son, en cuanto a sociales políticos, se encuentran las políticas del nuevo gobierno, por ejemplo, como el sistema que se va a crear, el Sistema Nacional de Aguas que comentábamos anteriormente. Habilitadores comunes financieros, como el Fondo Nacional de Desarrollo Regional, o los fondos institucionales chilenos como la CNR o el INDAP, y habilitadores comunes institucionales como la Mesa Nacional de Agua o la Agencia Nacional de Sustentabilidad y Cambio Climático, con su certificado azul y sus acuerdos voluntarios para la gestión de cuencas. Luego, y pasando a los habilitadores y barreras específicas para cada una de las soluciones, el esquema que les voy a presentar a continuación tiene en la parte de más a la izquierda la solución, luego presenta sus tecnologías, después sus habilitadores y posteriormente sus barreras. Entonces, para la solución de tratamiento y uso y sus respectivas tecnologías, nos encontramos con habilitadores financieros como el Fondo de Infraestructura y el Fondo para la Innovación y la Competitividad Regional. Luego, habilitadores institucionales, como la Ley de Servicios Sanitarios Rurales que comenté y expliqué anteriormente, y habilitadores sociales políticos, como la propuesta del nuevo gobierno de desarrollar una infraestructura relacionada con el uso de agua y de aguas residuales que sea resiliente y adaptable. En cuanto a las barreras para esta solución, tenemos barreras económicas o de mercado, donde entra el financiamiento de estructuras de saneamiento y la recuperación de sus costos, o el payback, es un desafío por el alto nivel de inversión que esto significa. Y acá voy a explicar una que va a ser común a las tres soluciones, y es que los esquemas de remuneración de las sanitarias no promueven en demasía la inversión en tecnologías avanzadas para este caso, tratamiento. ¿Qué quiero decir con esto? Que los actuales esquemas de remuneración y tarificación, en donde existe una tarificación para los usuarios de agua que está basado en un modelo estándar, no incentiva a las sanitarias a poder invertir en nuevas tecnologías. Tenemos luego barreras técnicas, como que la calidad del agua que ingresa a los sistemas de tratamiento puede afectar el desempeño de la tecnología aplicada, y para zonas rurales tenemos que existe una baja capacidad de mantenimiento y monitoreo de los sistemas de tratamiento. Barreras institucionales, como que el 44% de los problemas de la implementación de proyectos de agua está asociado a la atomización y desagregación de las instituciones de agua, y que otra que puede ser que existe una discrepancia entre los agricultores y las empresas sanitarias, principalmente a quién es el dueño de la reutilización del agua que fue servida y tratada. Por último, en barreras sociales ambientales existe un prejuicio lógico contra el uso de aguas residuales tratadas por parte de los usuarios. Para la solución de la optimización de la conducción, almacenamiento y distribución, tenemos habilitadores financieros como puede ser el Fondo Activa Riego de la Corfo, que financia el estudio de estos proyectos para su posterior implementación. Actualmente este fondo está cerrado, pero ayudó mucho en el pasado a la implementación de este tipo de proyectos. Habilitadores institucionales, como la Comisión Nacional de Riego, la CNR, que se dedica a incentivar obras privadas para la construcción y reparación de obras de riego y drenaje. Y habilitadores sociales políticos, como las promesas del nuevo gobierno que mencionábamos anteriormente, de promover la eficiencia y sostenibilidad en el uso de agua y en las obras de riego para la agricultura rural. En cuanto a las barreras para esta solución, encontramos barreras económicas nuevamente en los esquemas de remuneración para las empresas, pero esta vez asociado a los sistemas avanzados de conducción. Barreras técnicas, como la necesidad de identificar las zonas con mayores requerimientos de canales de regadío. Barreras institucionales, que nuevamente recalcamos la atomización de las instituciones. Y sociales ambientales, que podrían ser los conflictos con la comunidad, en caso de implementar proyectos como embalses, balsas y conducciones de agua en sistemas cerrados. Por último, para nuestra solución de optimización del uso de agua, tecnificación y automatización, encontramos habilitadores financieros, como puede ser nuevamente el Fondo de Corfo de Activa Riego, habilitadores institucionales, como la Estrategia Nacional de los Recursos Hídricos entre el 2012 y el 2025, que lo que hacía era promover o incrementar el incentivo a la inversión en este tipo de tecnologías, y habilitadores sociales políticos, como las promesas del nuevo gobierno de promover la eficiencia y sostenibilidad en el uso de agua y riego para la agricultura rural. En cuanto a las barreras para esta solución, en económicas, encontramos que existen altos costos de inversión para los pequeños agricultores, lo que desata varios problemas dado el precio de la tecnología y el riesgo crediticio que esto puede llegar a significar. Y también acá encontramos nuevamente los esquemas de remuneración para las empresas, pero esta vez asociados a sistemas de monitoreo. En cuanto a barreras técnicas, tenemos que los sistemas de riego están asociados a un gran consumo de energía eléctrica y probablemente se va a necesitar un personal calificado para realizar tareas como medir, registrar o analizar datos en caso que sea un monitoreo remoto. Barreras institucionales, nuevamente donde recalcamos la gobernanza atomizada, y sociales como la resistencia a la implementación de las nuevas tecnologías por parte de los agricultores. Esta resistencia se da porque muchos agricultores han ocupado una misma técnica durante mucho tiempo y cuesta cambiarle las tecnologías. Una vez que las caracterizaciones de las distintas soluciones ya fueron hechas, se procedió a dar recomendaciones sobre las acciones que se podrían tomar para ayudar a la inserción de las tecnologías del Reino Unido en el mercado chileno. Estas recomendaciones van dirigidas a cualquier empresa o institución que esté interesada en ayudar a lo anterior. Entonces, la primera recomendación, llamada preparación del mercado, tiene que ver con la barrera que mencioné anteriormente, común para las tres soluciones, de esquemas de remuneración identificados para las soluciones. Lo que se recomienda acá es llevar a cabo un programa de talleres para transferir la experiencia y el conocimiento del Reino Unido en esquemas de remuneración para empresas sanitarias, donde los talleres sean para cada una de las soluciones. En el caso del tratamiento de agua, talleres para incentivar sistemas de tratamiento, para la conducción, talleres para conducciones eficientes, y para la tecnificación del agua, talleres para mejores sistemas de monitoreo. La segunda recomendación, llamada licencia social para adoptar nuevas tecnologías, tiene que ver con un programa de seminarios enfocados a informar y sensibilizar a los stakeholders sobre la adopción de tecnologías. En este caso tendríamos que la solución involucrada sería para el tratamiento de agua, sería para los usuarios de agua potable y para los agricultores sobre las reutilizaciones de agua y el uso de aguas reutilizadas, explicarles que no son aguas malas y que se pueden ocupar. Y para la tecnificación del agua tendría un foco en los agricultores, donde se le explicarían las nuevas tecnologías de riego y sus beneficios y por qué deberían adoptarlas. Luego tendríamos el aprovechamiento del uso de las subvenciones públicas para adoptar las tecnologías del Reino Unido, donde lo que se propone es poder generar una vía para obtener los permisos y los trámites necesarios para poder acceder a los fondos que otorga Chile, por ejemplo, los fondos de la CNR o los fondos del Instituto Nacional de Desarrollo Agropecuario. Las últimas dos soluciones, la primera tiene que ver con una asistencia preparatoria para el desarrollo empresarial, donde se busca realizar un análisis preliminar de posibles implementaciones tecnológicas en las zonas que necesiten, y tendría el objeto de facilitar el trabajo para las empresas del Reino Unido. Acá hay dos soluciones involucradas. La primera es la solución de tratamiento de aguas, donde se propone hacer un análisis de posibles zonas con necesidades tecnológicas, como las zonas rurales, donde entraría también muy en juego la ley que expliqué anteriormente de servicios sanitarios rurales, ya que se van a tener que construir plantas de tratamiento en estas zonas. La segunda recomendación tiene que ver con la conducción del agua y en la identificación de zonas para la implementación de la construcción de canales. La última recomendación que proponemos son acciones económicas para incentivar la adopción de tecnologías, como puede ser la creación de un benchmark de tecnologías comparativas entre las del Reino Unido y las de Chile, donde se pueda comparar cuándo son más baratas las tecnologías y así incentivar su adopción. Respecto al financiamiento del proyecto, para las soluciones propuestas y sus respectivas tecnologías, se propone un pequeño diagrama de flujo para la obtención de financiamientos. Este diagrama entonces parte en la parte de más arriba a la izquierda con una identificación de un stakeholder chileno que tenga una necesidad por parte de compañías del Reino Unido. Luego vendría una etapa de diseño y y de diseñar y hacer los planes para la implementación de este proyecto. Y vamos con nuestra primera parte del flujo, que tiene que ver de si el proyecto va a necesitar financiamiento externo. Si es que no necesita financiamiento externo, se puede simplemente hacer el proyecto directamente con el stakeholder y se puede proveer el servicio directamente. Si es que sí necesita financiamiento externo, pasa a una segunda pregunta de si este financiamiento va a ser por parte de una entidad chilena o no. Si es de una entidad chilena, que en este caso tenemos más identificada la de la CNR o el INDAP, si es que no es desde una entidad chilena, se propone aplicar a un fondo internacional para obtener el financiamiento. Y si es que sí es con una identidad chilena, pasamos a la tercera parte de nuestro diagrama de flujo, que tiene que ver con si el proyecto tendría que aplicar al INDAP o a la CNR. Si es que el proyecto tiene menos de 2 hectáreas de riego básico, que es una medida estándar que se ocupa en Chile, y el stakeholders tiene un capital avaluado en menos de $140.000, se puede aplicar al INDAP y de caso contrario habría que aplicar a la CNR. Para el cuadro en amarillo y en caso de tener que aplicar a fondos internacionales, también se propone requerir, ¿no es cierto?, estos financiamientos externos para lo que se identifican algunos fondos climáticos internacionales que son aplicables para este tipo de proyectos y que proporcionan financiamiento concesional. Los fondos que se proponen acá entonces son el UK Export Finance, el Green Climate Fund, el Global Environmental Fund, el Climate Investor 2, el Arboview Capital y el Latin America Investment Facility. Por último, y para dejar en claro uno de los propósitos y que creemos que es una conclusión importante, hoy por hoy es muy importante armar pipelines de oportunidades y poder establecer las vinculaciones con los distintos actores chilenos, entre los del Reino Unido y los chilenos, para poder obtener oportunidades comerciales y así generar el desarrollo de todas las soluciones y tecnologías mencionadas anteriormente. Muchas gracias.
Thank you very much, Martin. I've been told that some of the people in our audience is not being able to use the chat box to add comments or introduce themselves. The question and answer area or section is working properly, but Martin, if you can help us enabling the chat box, that would be great. So our audience can put also their comments there.
I will enable the chat, Sebastian. No problem.
Okay, thank you very much. And our Q&A section is working properly. We've been receiving a couple of questions already, and we'll be discussing those during our Q&A section before the end of this webinar. Now, please let me introduce to you Eddie Maloney, our next speaker. Eddie Maloney is the head of water at the Department of International Trade, or DIT, of the UK government, and he specializes on supporting UK companies to work on water projects internationally. Eddie works with DIT overseas teams in UK embassies and high commissions and government colleagues across the UK. Eddie supports DIT international teams to build relationships and to identify and facilitate discussions on sustainable water projects. He works with UK companies in the water supply chain to support their involvement in international water projects. So I leave you now with Eddie. Thank you, Eddie, for joining us, sharing this presentation with us today.
Thanks, Sebastian. Good morning and good afternoon, everyone. The presentation that I'm about to give is mainly for an international audience. So it's mainly for the audience in Chile, but there are lots of UK case studies within it. So for the UK companies that are listening, I'm always looking for more case studies because they will then feature in this type of presentation, or they go into subsector specific presentations such as leakage, flood resilience, etc. So do send me some other slides. Next slide, please. So this is what I'm going to cover today. I'm going to talk about climate change, urbanisation and water scarcity. These are all global water challenges. And I'm going to put that into a UK context because these challenges are occurring in the UK as well. I'm going to discuss the UK water sector, give a little bit of information on how that's structured, what its priorities are, and so on. And then I'll talk about Department for International Trade in the water sector, what it is that I'm looking to do, how I'm working with Chile and other places. And then lastly, I've got some case study examples, which I will look to share. Next slide, please. So this is a slide that I use to talk about why water is a priority. Why is it a priority globally? And the very first statement at the top there says that water only produces 1% of profits for business, but 99% of businesses need water to succeed. And this was a comment I saw around about the time of COP26 in Glasgow back in November. I think I saw it on LinkedIn, but I thought it was very apt. And there's a good example that's happening in Germany right now. You'll all be familiar with Tesla, the electric vehicle car company. They are struggling to open a factory in Germany because they can't get permission for the water extraction that they need for that factory. I thought that was very, very apt. Now, the other points that I've made there, the first bullet point does capture it very well. It's the combined effects of growing populations, it's urbanization, it's climate change. You've also got rising income. So therefore, all of that combined means the demand for water and water services is rising. And equally, because of climate change, the volume of that water and how we get that water is changing. And then at COP26, for the first time ever, there was a water pavilion. So there hasn't been one before. And that was fantastic to allow water officials and ministries to come together and take part in 2 weeks where water and climate change were discussed. And I believe that's going to continue at COP27 in Egypt later on this year. The third bullet point here is looking at a World Bank report, and there's some links in my presentation so you can go read more of this. And it looks at a severe drought and how that is having an impact on GDP. And I think this study was in Ethiopia, but as Martin said earlier, what is there, a 10-year drought, I believe, or the ambassador said a 10-year drought in Chile, and obviously that's a negative impact on the GDP. And then the final point there, is just an IFC report talking about climate smart water solutions. And it's saying that the market could be up to valued of $1 trillion by 2030. Next slide, please. And this is Sustainable Development Goals, which I'm sure everyone's familiar with. So lots of different challenges. I'm not going to dwell here, but there's lots of issues. And it's important that water and water services are it's an increasing priority for governments globally. Next slide, please. Now, this is starting to put climate change into a UK context. This is a project that's been running for 20 or 30 years in the UK. It's called UK Climate Projections. It's run by the UK Met Office, but it's partnering with regulators in Scotland, Wales, Northern Ireland and England, and lots of other partners are involved in it. What this project shows, it produces lots of data sets, but it shows what UK weather patterns will be like in 40 years' time. So from 2061 to 2081. And in really simple terms, all of the UK is going to be much drier. We could have severe droughts ourselves in parts of the UK. And equally, we're going to have more extreme weather events. So we're going to be much wetter in the winter. So the challenges there are, how do we capture and manage the water we get in the winter, ensuring we're not having flood problems, and then storing that water so that when we've got drought periods in the summer, we've got the water availability. So our utilities and others are using these data sets already. Next slide, please. This is the name of a speech, Jaws of Death. So this speech was given by Sir James Bevan, who's the Chief Executive of the Environment Agency. And he gave this speech back in March 2019, and it got a lot of traction then. And he used the same terms and he talked about weather bombs when he delivered a similar speech in February this year at an event called World Water Tech that DIT and others are active at. And in simple terms, what he was saying is that if the UK takes no action, parts of the UK in 25 years will run out of water. And that's what he meant when he talked about the jaws of death. It's that rising demand for water and then meeting the lower amount of water that's available. Next slide, please. And this is just starting to then look at what does the UK water sector look like? Well, we have about 20 water utilities in the UK. And Scotland, Wales and Northern Ireland, the utilities are still largely government owned. In England, the utilities are owned by investors. But the common theme across them all is that there are, generally speaking, 5-year asset management plans, where business plans where they're looking at what needs to be achieved over this next 5-year planning cycle. But equally, the sector's also looking at its 25-year strategic plans, and they cooperate much more now than perhaps they ever did. But the other common theme across the whole of the UK water sector is it's highly regulated, and we believe that drives innovation across the sector. Next slide, please. And this is an attempt to put some bullet points together to try to explain what some of the UK regulatory process looks like in terms of how that links into a water utility. So what we see every 5 years for that annual planning cycle is the UK government will set out strategic objectives for the water industry. And then Ofwat, one of our main regulators, and other regulators will then work with industry through that planning cycle to take informed decisions on how those objectives are going to be met. And so, for example, there, it might be that Ofwat's looking for, and all of this now has to reflect the clean growth agenda. The UK government is committed to be net zero by 2050. As the ambassador said, Chile is also committed to be net zero by the same date. Interestingly, the UK's water utilities have agreed to be net zero by 2030, Scotland in 2040. And what will be interesting there is it will be the UK supply chain that will be providing solutions so that the industry can meet that 2030 target. Next slide, please. And this is trying to capture some of the strategies that we're seeing coming out of the industry. So obviously climate change is a major driver in the UK, so planning for future needs. So the UK industry is looking to be resilient. It needs to create, or already is a resilient water sector, but how can it continue to be resilient? So that's better looking after existing water resources, ensuring that we have water security. But it's important that we look after the environment. There's increasing lobbying in the UK. And then the other angle there is the customer. That there is a lot of customer engagement in the UK in terms of how we manage water resources. And then the other bullet point there is flood resilience. I talked about net zero water by 2030, and there's a figure there of between 2 and 4 billion investment that we believe will happen in the next 8 years in order to achieve that. There's also a water innovation strategy to 2050, and again the links there, and that was all of those 20 utilities coming together in order to look at what innovation do they think is needed by 2050 so that things can still operate. And then the industry's also come together to launch a leakage route map to 2050, and that's just to give the industry ideas about how to improve leakage, and again you can read that online. Next slide, please. So this is a slide on research. So I mentioned that innovation strategy, that's pulled together and published by an organisation called the UK Water Industry Research, UKWARE. So they've pulled that together, and they act as a coordinating body for the whole industry. So some of the other initiatives that are happening, Ofwat, one of the main regulators, has launched an innovation fund. What's interesting about that is it's designed to encourage collaboration. So if Thames Water, one of our utilities, were to bid for the innovation fund on their own, it's likely to be rejected. If Thames Water get together with Anglian Water, some universities and some companies and make a collaborative bid, it's got a better chance of being funded. And then another initiative that UKWARE have launched is a platform called Spring. And this is an online communications platform that allows utilities to post challenges that says, we're really struggling with this area, we're interested in companies coming to us with solutions, but equally it allows someone with an innovation to go and communicate through that portal, and then it will reach the utilities. Next slide, please. So this is looking at water priorities within the Department for International Trade. So I've touched on these areas already. So water resilience is important. Circular water economy. Circular economy is starting to become a much more accepted business term. Net zero water, as I've mentioned, and then digital water is another area. But the main approach that the DIT has is to look at relationships. So my role is to work with DIT in Chile, DIT across Latin America and the Middle East, India, etc., and to help them form relationships with water ministries in their markets, with water utilities, contractors and others. And we see that as the way that we can then support UK companies to be involved in international water projects. And that sort of work's ongoing in different places. Next slide, please. And this is just the relationship model, trying to put it in. So the other group of government people I link to are UK government people across the UK regions. So I link into people across England and Wales, Scotland and Northern Ireland, and those UK government staff manage or work with UK companies. That's a key point. I also link into various industry bodies. I've mentioned UCWA already, so I work closely with British Water. I'm doing one of their events tomorrow. I work with the Future Water Association, the UK Water Partnership and others. And then you can see some of the companies I work with on the right-hand side as an example. Next slide, please. Now, this is the UK Water Partnership. I mentioned they're one of the organisations. So this is a water resilience white paper they published last month, and it's useful. You can download it now. The link's in the presentation there, but it defines what do we mean by water resilience, which is useful in itself. But then there are lots of case studies within the paper where there's lots of examples in the UK and internationally of water resilience solutions. And again, for the UK companies listening, the UK Water Partnership are looking for more case studies that will then feature in the online version of this paper. Next slide, please. And this is another paper that the UK Water Partnership released about 18 months ago. Next slide, please. And these are just a screenshot of some of the case studies. So again, you can go download that paper and read it at your leisure. Next slide, please. I've got two holding slides now, this one and the next one, and they're just really holding slides for examples. I've got some case studies now on the UK water sector. So the UK has got capability across the full water cycle, whether that's in leakage or water sourcing or tunneling or flood resilience, etc. Next slide, please. Some other examples in this holding slide. Even in desalination, the UK doesn't have a full desalination offer, but we've got the solutions that go in and around that desalination project. So that's the advisory services, it's the monitoring, and it's the water sourcing, etc. that's needed for the desalination. Next slide, please. I'm now going into some case study examples, and this is the first one. It's a project actually in Scotland, and the image in the bottom of the screen there isn't very large, but that's the Forth estuary. And if you were to follow that purple image all the way up to where it starts to go green, Edinburgh is in there somewhere. And so this is a project that's going to create a digital twin of a full catchment. So it will be a digital twin of that full estuary, but also of the rivers north and south of that estuary. And so it's actually a live project just now. There's tenders going out for the sensors and other associated technology for this project. And so it will monitor water quality, it will monitor river flow, water flow, flood resilience, etc. So it's very much a satellite-based solution, but using on the ground and underwater sensors, and then using artificial technology and data processing. And the idea is it will give real-time information to people who need it. So that will be the water utility, it will be the water regulator, it will be businesses. And interestingly, one of the businesses that's involved in this is Diageo, the drinks manufacturer. They need access to this data for the water that they're taking into their factories, their drinks factories, but equally for their effluent discharge. This will be relevant. Next slide, please. This is something I found on LinkedIn. Someone posted this image of a technical report on leakage from March 1981. So I haven't read the report. Might be quite interesting to read it, and I thought I'd use it in a presentation. But leakage is a global problem. It's a problem in the UK. It's a problem internationally. And there are some stats here, depending on whether you go to the World Bank or another source, the volume of water that's leaked tends to be astounding. And so there's various management strategies that can be taken forward. And I've got some examples of that. Next slide, please. So this is the Water Research Centre. It was their booklet on the previous slide. The Water Research Centre are one of the UK's consultants. It used to be part of government and it was privatised a number of years ago. But this was a study with one of the UK's utilities. And it was looking at a failure analysis and predictive modelling to support their maintenance strategy. Again, very much related to non-revenue water leakage. Next slide, please. Another couple of leakage examples, a company called I2O. We're working with Manila Water in the Philippines, and it's a pump pressure optimization system. So looking at leakage as a problem or a leakage solution that's coming at it from a completely different angle. There's another WRC example there, similar to the last one, but slightly different. Again, costing what leakage solutions might be available to a utility, so that utility could prioritise. Next slide, please. Another leakage example, this is a 100% artificial intelligence solution. And what FIDO do is they work with any other company's noise loggers. They don't generally use their own noise loggers. They will go to a utility and take the audio file. And as long as they've got the audio file and the data from where that's come from and where the noise loggers are, etc., they can accurately tell you where the leaks are, how big they are, which then again helps organisations prioritise. And you can see they're working with a number of UK utilities and a number of international players as well. Next slide, please. And this is a company, CamNexus, that I believe are already active in Chile. And it's more of a water management solution. It's using communications technology. So we're now in the 5G era, which has been rolled out in the UK just now and rolled out in lots of other countries. But this is all about providing data and information to industrial users and operators on the ground, and it can work in an agricultural sense, but for other users as well. Next slide, please. This is a live research project, so excuse me, you can't actually buy this product just yet, but it's under development, and it's a company that's working with the Welding Institute in Cambridge. They're a famous institute that's developed welding solutions, new welding solutions for shipbuilding, for example, that are now used globally. But this is obviously for plastic pipes and it would be used in the water sector. So this is a new solution that hopefully once it comes to market will be quicker and more efficient, for use. Next slide, please. This is a company I happened to visit about 2 years ago now, Blackhall Engineering, and their pitch, if you like, one of their sales pitches is our valves are guaranteed for 100 years. And they're able to say that because they've got valves still operating in the UK that were installed over 100 years ago. And it tends to be large valves. This one's, I believe, 40 feet. And you can see in that image there is a man standing beside that blue valve. And this was a project out in the USA in order to increase the water supply to the city of Dallas. So again, an interesting company that perhaps this valve is more expensive than other cheaper valves, but it comes with that guarantee. Next slide, please. This is an nature-based solution. Another one of our consultants, Arup, were involved in a master plan for the urban region of Shanghai. And this was a project where Shanghai were looking to spend about 40 billion, but wanted to look at a more green solution. So Arup revised everything because the Shanghai government are looking at more green solutions rather than grey infrastructure. So it's looking at nature-based solutions, sunk squares, and various other solutions there. Next slide, please. Looking at catchment management, there's two examples here. Atkins, again, another one of our consultants, was looking at river basins around China. China, again, is another water-stressed country. If you look at somewhere like Beijing, 20 million people, it really struggles for water. And the other example on the bottom there is the British Geological Society published a report looking at African groundwater and how important that is for climate change. And I'm sure I read something 2 or 3 weeks ago that the belief is that groundwater and proper groundwater extraction, managed extraction, will be key to Africa's growth in the next 20, 30 years. Next slide, please. This is just some other examples. Water sourcing, Mott MacDonald providing a report to the World Bank looking at hydropower and dams. On the right-hand side, HR Wallingford working with Motts, involved in a dam project in Pakistan. And then down the bottom is ADAS working with our UK Met Office, looking to provide better Met Office data, weather data to agricultural users. Next slide, please. This is a wastewater treatment plant. It's in the Middle East, in Bahrain. It's a company called Blue Water Bio. The interesting fact about this wastewater treatment plant is it was at 100% capacity, but the city that it served obviously was expanding, and so the plant had to expand and there was no real room for it. So this solution increased the capacity by 150% without really taking up any more available land. But interestingly for the solution is it allows for better water reuse in the agricultural industry and other industries, etc. Next slide, please. Another sludge example. This is a thermal hydrolysis plant near Birmingham in the UK. And the interesting thing about this is it's using the exhaust gases, capturing that from the process and turning it into heat for UK homes. So this plant, as well as being a more efficient sludge management process, is heating, I think it's 3,000 homes. And the other thing I like about this slide is the number of UK companies you can see in the bottom right there. And you can also watch the video. It's also a digital twin solution, so you can watch the video at some point. Next slide, please. Next slide, please. The video, you can pause the video. Oh, Martin, can we move to the next slide?
Sorry, what?
Next slide. I don't need to see the video.
Oh, all right.
Okay, thank you. So this is another UK consultancy company called the Centre for Ecology and Hydrology. And they've got lots of river data across the UK. So all of our water utilities would use CEH's data sources for lots of different projects. So if there's a flood resilience solution that needs to understand what's happening in a river, it's likely they will use some CEH data. But they also work internationally. And nowadays, with artificial intelligence and modeling technology and data centers, they can help overseas nations create similar data using modeling technology. Next slide, please. Coming to the end, I've got a couple of examples on tunnelling that was mentioned in Martin's presentation. So the UK's got world-leading expertise in tunnelling. We've got a project in London called Thames Tideway, which is a deep sewer tunnel taking stormwater sewage away from the city centre. But we've got rail tunnels, you know, Crossrail and HS2 are the two main examples. Next slide, please. And this is you can see an image of London here. So this is the Thames Tideway project. And the reason for showing this slide is it's a complex project because you've got the underground right next to the tunnel. So that's a complex issue in itself. But you also don't have available land where the normal construction footprint would take place. So all of that construction equipment has to be on the river. So it's all done by barge. Next slide, please. And this is just a bit of a case study slide on the Thames Tideway project. I'm not touching any of this, but there's some information there about the length, the depth, etc., etc. But what I do like about the slide is the bottom left shows a complete range of different companies that are involved, lots of UK consultants, but technical surveys, etc., project management companies like Mace, Turner Townsend, and so on. Next slide, please. And this is my last slide that I will finish on, and it's just core strengths of the UK water sector. And I've highlighted three. The UK is known for quality projects and products and services. The UK does have global expertise active all around the world. And then hopefully, as you've heard today, the UK water sector is an innovative sector and continues to innovate. So that's me finished for this afternoon. I hope that presentation was of interest and happy to answer any questions. Thank you.
Thank you very much, Eddie, for that very nice and complete presentation on the water UK industry. Very, very nice examples, and I can see how this expertise from the UK could help addressing partially at least the solutions that Martin commented at the first presentation. So now we will start our Q&A section. This will be moderated by our colleague from Implementasur, Hernan Lopez, who I already introduced to you a few minutes ago. So thank you, Hernan. You can go ahead.
Thank you, Sebastian. Well, hello to everyone, and I'm really glad to see the amount of people that have attended this webinar. Thank you all for being here with us, and also I will thank for all the questions. We have received a good amount of questions, and I will look forward to address them all during this couple of minutes that we have. If there is any other questions, we will leave our emails also in the chat section, so you can write us directly and we could discuss more about this really interesting topic. So first of all, I will start with a question regarding the indexes that Martin presented at the beginning of the agriculture statistics and the main companies involved in the agricultural sector in Chile. And here, Justin has asked if aquaculture was included in that statistic. And here I will answer that question directly, but I will say that aquaculture was not included. Here we are only considering agricultural companies that are involved in the export market of agricultural products in Chile. So yeah, aquaculture is, even though it's an important sector in Chile, it was not included in that list. Okay. I don't know, Martin, if you have any other thing to add, you can just interrupt me. So I'll move forward. So here, Walter Ojeda asked for the budget of the CNR and INDAP, those just to give you a brief recap. Those are institutions that are finance water infrastructure projects in Chile. And here, I believe, Martin, you could answer that question.
Thank you, Hernán. Hola, Walter, muy buenos días. Respondiendo a tu pregunta, primero recalcar que el Instituto Nacional de Desarrollo Agropecuario maneja mucho más presupuesto que la Comisión Nacional de Riego. Y particularmente en el año pasado, la Comisión Nacional de Riego administró 20 millones de dólares que fueron en beneficio de 250 proyectos. Y para el INDAP, el presupuesto que administraron y que dieron fue de 40 millones de dólares. Así que esa es la proporción 2-1 a favor de INDAP en presupuesto manejado.
Thank you, Martin. So now I'll take the following question. Here. Okay, so a question for Eddie Malone. So Daniela asked if Eddie, you could explain a little bit further about the net zero water concept. I believe we are all familiar, or we all know the net zero concept for carbon emissions, but I would love if you can go a little bit further in the net zero water concept.
Okay. Yeah, so it is all tied into carbon emissions. So countries are committing to be, the whole country, to be net zero by 2050. So the UK has committed to that, Chile has committed to 2050. And it's all about how do you then reduce the amount of carbon that's part of an ongoing project. So it can even be a road building project using concrete. Can you use carbon zero concrete? And there are the big concrete manufacturers, including Cemex from Mexico, are looking into how can they make concrete and cement without, you know, a carbon neutral solution. So in the sense of the water sector, the water sector has just made the same commitment, except to do it 20 years earlier. So if you look at, and it's a commitment in the English water utilities. So Scotland have committed slightly later, but with a slightly different definition. So it means that the utilities in England are looking that by 2030, they can confidently say that they are not producing, they're operating at a carbon neutral basis. So they've looked at everything they do, and there are some quick wins, there are some simple wins. So for example, a lot of the water utilities have got diesel trucks and vehicles. So they're all getting rid of them. They're all going to be electric vehicles. So that's an easy win. That's relatively straightforward to do. But then there's things about how can we bring more renewables into the water sector and make renewables part of it. And then it's things like your waste treatment facilities. So some of the waste treatment facilities in the UK are pretty old and have been operating the same way for probably 40, 50 years. And they will produce exhaust gases that aren't good for the environment. And if you measure that properly, they aren't, they won't help meet the carbon definitions. So it's how do you change an old-fashioned an old-fashioned waste treatment facility and upgrade it so that it becomes carbon neutral. So that's where you're looking at, you know, perhaps some of the processes that the example in Minworth. So it's all about the industry itself. So the water industry in 2030 being able to say our whole industry is carbon neutral. And just to finish, the last thing is it needs innovation to do that. It's not going to be easy. The industry itself doesn't think it's an easy task to be net zero by 2030. And so there's lots of conversations and lots of studies and lots of sharing of ideas about how are we going to be net zero by 2030.
Thank you very much, Eddie. So here I'm also reading Jessica that asked Well, first of all, thanks for the presentation. I have a question regarding your analysis for barrier and technological solutions in the area of network and pipes monitoring. I see that the barriers presented are mainly related to smallholders farmers. Do you identify barriers in the uptake of technology in the urban water utility sector? Here, I don't know, Martín, if you can answer that question.
Sí, claro. Muchas gracias, Jessica, por tu pregunta. La respuesta a esa pregunta viene, efectivamente, se encuentran muchas barreras para la implementación de proyectos de monitoreo en términos privados y agricultores, pero también hay una barrera súper principal y que la mencionamos durante la presentación, que viene relacionada al monitoreo para water utilities o sanitarias, y tiene que ver con eso que de la remuneración de los esquemas de tarificación para las sanitarias. ¿A qué hago referencia con esto? Que hoy por hoy las sanitarias en Chile tienen un sistema de remuneración en donde a sus clientes se les da una tarificación que está estandarizada en base a un modelo. O sea, a principio de año, todos los años, se hace en base a un modelo estándar, se da una tarificación que es igual para todos los clientes. Entonces las sanitarias no tienen mayores incentivos a invertir en, por ejemplo, tecnologías de monitoreo, porque no los van a ver reflejados en sus utilidades.
Thank you, Martin. So here also I have a question regarding wastewater technologies. And here Daniela is asking if that will be something for urban consumption or using in situ or using on-site that water, that wastewater treated, and also what type of technologies were evaluated. And here I would just like to do make a disclaimer that during the study, something that we focused on was to identify commercial collaboration opportunities between the UK and Chile and identifying those barriers, and also what sectors could be more interested for both countries to collaborate with. But it's something that was not part of the scope of the study, was to identify all of the solutions for each one of the categories that we have described before. Still, something that we had identified during the interviews and during the literature review is that for Chile, the main technologies that is being evaluated for wastewater projects is the activated sludge. And here's what we have identified for wastewater sector was not only for urban consumption, but also for agricultural consumption, considering the creation of new water resources, especially in zones where water availability has decreased over the drought of the last 10 years. So here, also Christian is asking if we will share the presentation, and I don't know, Sebastian, if you're planning to share the presentation with the audience, but I will leave that to you.
Yes, we're actually recording this webinar and we will share it with the audience later on. I have to check with the panelists to see if we're authorized to share the presentation. If that's all right, we will. But we will anyway share the webinar recording.
Great, perfect. I believe there are a couple of questions left, but as I just mentioned, we'll leave our contacts. So if you want to contact us and discuss a little bit further this kind of these topics, we're completely running out of time. So I'll just pass the lead to Sebastian so we can start closing our event, and I will just give a big thanks for everyone that has attended. I believe it's and for the good feedback we have received through the question and the chat section.
Thank you, Hernan. Thank you again for joining, all of you. We had around 80 people at some moment during the webinar. We are very happy for this. I'd like to say once again that we will continue working from the embassy during the following months to promote collaboration between UK and Chile in the water sector. Again, please do reach out to us with your ideas and comments. We will be also sending a survey to all who attended today, and your answers to that survey will be more than appreciated to strengthen our work. That survey will be sent probably either today, at the end of the day, or maybe tomorrow. So with that said, thank you again also to the panelists. Thank you, Implementa Sur, and thank you very much, Eddie Maloney. You have been a key person supporting us in this project. We are finalizing the webinar now. Thank you all. Have a good day. Goodbye.
Thank you very much. Goodbye to all.
Yeah. Thank you.